let's go through LICO 2291, max profit from trading stocks. For this question, it gave us integer represent, which represents the current price of I stock for present I. And for future I, it is I stock a year, the price of I stock in a year in a future. And you have budget. That means what the stock you buy cannot exceed the budget. You can you do not need to use all of the budget, but it asks the maximum amount of profit you can make. So we'll see for this question, for every stock we can buy or not buy, right? So it is pretty much like we consider something like one series DP, but if it has a budget here, right? Has budget, so that means we have some kind of limit. So for this kind of question, we're thinking about like pretty much like a traditional classical backpack problem. So let's say let's start int a equals present dot length. We're going to use so that means we need to have we have n stock to choose, and also we have budget as the another dimension for our DP, right? So for every stock we can choose to buy or not buy. So this is a classical 0-1 back problem. For classical 0-1 back problem, we can write two-dimensional DP, right? And also we can change this to one-dimensional a bit later. So it will be n plus 1 and budget plus 1. So we'll say this DP ij will mean, or that this one mean will be the previous ice stock, right? And J budget max profit. So we'll say that DP ij will be the max stock max DP I minus 1J. That means we just use I minus 1 stock. It uses J's budget and the max profit, and also the DP I minus 1 J minus present. So I will have I minus 1. If we want to have this, that means we are going to buy the I stock and plus the current profit I or profit I minus 1, right? If we have one more index, that is future I minus 1 minus the present I minus 1. So for 0-1 problem, right? So we need to write two for loops for int I equals 1, right? Because we are calculate from 0, right? We have one more index I smaller than n plus 1 I plus and for int. But G, that is from 0, right? Because it may have some cases that the budget is 0, and the J smaller than budget plus 1, J plus. Yeah. So we'll have DP I J equals DP I minus 1J at least, right? So that means our max profit use previous I stock. We can be at least use previous I minus 1 stock, the same budget, the value, right? So it will not smaller than the max profit. We have less choice, right? So let's say if J is greater equal to then minus 1. That means I can for this budget we can buy current stock. So we have one more choices, that is DPI J equals max spot max DPI J and the DP J minus present I minus 1 plus profit. The profit is future I minus 1 minus present I minus 2. In the end, what we need to return is just a return DPA budget. Next, should be, this is also I minus 1, we should have this 2 dimension. I minus 1. Doing like this is a multiple by budget time complexity, but we know 0, 0, 1 backpack problem. The things that every DP it had coming from 2 values. That is the DPIJ is from the DPI minus 1 J, right? And also the DPI minus 1 J minus something, and so coming from these 2 values, right? These 2 values. So we know for this kind of formula, we can change this one to be 1-dimensional DP. And when we loop, it is instead of from left to right, because it's coming from these 2 directions. We need to loop from the end to the left. So if we change this one to 1-dimensional DP, we can get rid of the first the n, right? Get out the n's this kind of the we'll have just a DP budget plus 1, and the length to be plus 1. And what we need is we know for this for J loop we should have a reverse direction. So we'll have in J equals budget and J plus equal to greater equal to present I minus 1 J minus, right? And we have BP J equals max BP J and BP J minus present I minus 1 and plus the profit, right? So that is this profit is this. So in this case, we don't need a 2-dimensional, right? We just use a 1-dimension DP here. Okay, doing like this way, the time complexity will still be A multiplied by budget. And the space complexity will be O budget.